So, you can all hear me? So, hopefully you're here for what's new in the macOS SMB client. If you're not here, then you're in the wrong session. Start off with who am I? This is actually me, like in 1990 or so. Can't quite see it, but there's actually a boombox in the back corner. I have 2 CRT monitors, and I'm learning stuff by looking at giant paper manuals. But who am I? I'm Brad Suinn. I'm a network file systems engineer at Apple. I joined Apple in late 1989. I started off in the QA department for several years. From about 1993 or so, I've been a development engineer. To give you some context, the very first project I worked on at Apple was the Macintosh 2FX, which ran the Motorola 68030 at a blinding speed of 40 megahertz. It had 4 megabytes of RAM, and you could expand it to 128 megabytes. And it came standard with an 80 megabyte hard disk drive that you could expand up to 160. And at that time, our OS was System 6. Things I'm going to cover today. A lot of stuff to cover, so I'm not going to take any questions until the end because I hope to get through all of this. But we're going to go over ceiling algorithm updates, multi-channel, something we call bracketed throughput algorithm, file leasing support, Spotlight over SMB, tiered and online-only file supports, and then finish off with shadow copies and SMB Timewarp support. If you have your SMB acronym Bingo card, this is the great presentation for it. So, start off with ceiling algorithm updates. This was introduced in macOS 12 Monterey and continues on. So, from that version on, we support SMB 311, which means we support the pre-authentication integrity hash check. And that's the code which detects man-in-the-middle attacks, attempting to downgrade the protocol and the capabilities of the client or server before you finally finish the session setup exchange, and then you can turn on signing. We now support the negotiate context, and specifically we support the encryption capabilities one. We now support AES 256 GCM, AES 256 CCM, and then the previous versions of AES 128 GCM and AES 128 CCM. So that was a short topic. We move on. Multi-channel. You know, because of those COVID years, we released several OSs, and we didn't have a chance to ever talk about what was in it. So this actually got released way back in macOS 11 Big Sur. So first thing I'm going to talk about is how we discover different channels. So the first time you connect to a multi-channel capable server, we create a client network interface controller list, NICs. We'll just call them NICs. So we create a NIC list. The NIC list is essentially just what are the NICs that are in the client. And we'll update this NIC list if you add new network interfaces to the server or to the client, or you move it. The server NIC list comes from the server, from the ioctl that we send over there to say query network interfaces. So now we have the server NIC list. That list gets updated every 10 minutes or so in case the server adds something. We create a third list. And in this list, it's the possible channels to the server for each client NIC. And of course, we exclude the current connected client NIC because you're already connected to the server. Each of these list entries has a link speed, which is the min of either the client NIC speed or the server NIC speed. If the server supports RSS, then by default, we limit it to just 4 client NICs. Okay. This third list is sorted in order of the fastest link speed to the slowest. And by default, we prefer wired over wireless. Okay. So now we have this sorted list. Now what we do is we enter what's called the trials phase. And what we do for the trials is we start from the list, and we start with the fastest link speed. And each trial attempts to do a TCP connection to the server. And if the TCP connection actually works, then we actually go ahead and we try and actually do the session setup, and we try and do the session binding. Okay? We do these in parallel, up to about 16 of them. We do 1 trial per client NIC to the server. Again, we exclude the currently connected client NIC because you're already connected. If a trial fails, so let's say we try and do the TCP connect and it fails for some reason, we can't reach it, that particular client NIC will then go on to the next server NIC and try that and see if it can connect. And again, if the client interfaces or the server interfaces are changed, then we do a whole new set of trials to see what's available. So an example. In this case, you have a client computer. It has a 10 gigabit Ethernet, a Wi-Fi, and a 1 gig Ethernet. So EN0, EN1, EN2. The server has a single 10 gigabit interface. It's IF index 10, and it happens to be RSS capable. The user, when he connected to the server, he ended up using EN0. And of course, since there's a single server NIC, he just ends up with the same IF index 10. Because he connected over EN0, we automatically exclude it from the trials. So the client NIC list will be those 3 interfaces. The server NIC list will be the single interface. Our sorted list in order of fastest to slowest would be EN2 and then EN1. And it also turns out because EN1 is the Wi-Fi, we bump it below anyways. When we start the trials, we immediately connect from EN2 to the server and then EN1 to the server at the same time. And then we come back with a list of established channels. So in this case, assume like both of the EN2 and EN1 both were able to connect to the server. Okay? So now we have a whole bunch of channels that we could potentially use. Move into something that we called active versus inactive channels. So we pick the channels which all have the same speed and which all happen to be the fastest link speeds. And we designate those as active channels. And you could have 1 or more. You can have as many active channels, but they're all the same speed and they're the fastest speed to the server that we could find. Okay? For the active channels, we will route all of our SMB traffic over the active channels and we'll round robin from channel to channel. Okay? The inactive channel, we find the next fastest channel that got established to the server, and we will keep 1 of them as inactive. And it's inactive because we actually will not send any SMB traffic over it. We'll keep the channel there, it's just idle. If all the active channels fail, then the inactive channel is promoted to be the active channel, and then we start new trials to figure out who are our new active and inactive channels. Okay? And once the current inactive channel gets promoted to the active, then again, we look for what is the next fastest channel. We keep 1 of those, and he becomes the new inactive channel. If you're not an active channel or you're not the sole inactive channel, then we will disconnect all the remaining channels. I guess I should use this. Just for a little bit of note keeping, we have, among the active channels, we will designate one as the main channel. It just holds some internal state tracking information for us. If that main channel happens to go down, we just transfer that information to another alternate channel, and that alternate channel just becomes promoted to main. All other active channels will be designated as alternates, but they're all pretty much the equivalent. It's some internal state keeping for us. So when do we ever do failover or reconnect? Well, if an active channel goes down, then any pending traffic is automatically failed over to the next active channel, and we replay it. You set the little SMB replay bit saying, hey, we're sending it again. When the last active channel goes down, then the inactive channel is promoted to active, and again, any pending traffic is now replayed over the inactive channel. If all your active channels go down and we have no inactive channels left, then we attempt to reconnect. So we added in some ability for you to debug what our multi-channel code is attempting to do. So we added a new SMB util multi-channel so you can view the current channel status. We added some options into our nsmb.conf so you can enable or disable multi-channel. We did add a preference that if you have, for some reason, a super, super, super fast wireless network, which is faster than any sort of wired network, then you can turn off that preference, and then we'll just sort the list by whatever speeds we find. Added a new log level so that you can actually view all the multi-channel logging. You would actually see events saying, you know, connecting to this, you know, starting trials for this, you know, this channel was found, stuff like that. Again, you can man nsmb.conf or man SMB util for more information. Hopefully you can read that in the back. So here, this is the SMB util multi-channel. You can see that we have 2 active 1 gigabit Ethernets. If I can figure out how this works. So it says session active, session active. You got the speed over here. They're both 1 gigabit. We have 1 inactive channel, which happens to be Wi-Fi, which supposedly is reporting a speed of 248 megabits. Over here, you can see the M. So EN0 is currently designated as the main channel. All other channels are designated as alternates. The server, actually, in this particular case, has 3 different NICs. So you see the different server IP addresses, 30, 87, 88. And then the client has 2 Ethernet built in, or 2 Ethernets, and 1 Wi-Fi. Next topic, bracketed throughput algorithm. This is how the macOS SMB client tries to optimize the read-write throughput. So we have 3 sets. We have the min, medium, and max. When we try the min set, it's 8 I/O requests of 128K reads or 256K for writes. For the medium set, we have 8 I/O requests of 512K, and for the max, we have 6 I/O requests of 1.25 megs or 1 meg writes. These are the number of requests that we try and keep in flight all at the same time. So as each one completes, we'll just reissue another one. But in the min case, that means we try and keep 8 I/Os in flight of those sizes. We try the min, medium, and max, and then for each set, we actually calculate the bytes per second throughput. Okay? And then whichever set had the fastest throughput, that's the set we're going to use. But we'll only use a set for 60 seconds. And then the next I/O will check it again. So the idea is if your network suddenly gets congested, then maybe the smaller request of 128K would actually be faster. Or if when you first started the I/O transfer, the network was super congested and we were using the smaller sizes, but then network congestion went down or the server load went down, then maybe we would get actually better throughput with the larger I/O request. So we'll kind of keep changing it and we'll keep checking it. We selected these values just upon past experience. We find that these values work very well for various situations. Again, we added a new log level into our nsmb.conf. You can set it for log level hex 4, and you can view the current values and the throughput results. So again, an example. Again, I thought it would be bigger. I don't know if you can read it. But what you see here is we're getting this is actually a Finder copy to the server. So it's a bunch of writes. Finder is giving us a 64 megabyte block to send. In this section here, you could see us doing the Mac size. So it's, where is it? Oh, it's 6 requests of, in this case, 1 megabyte. Then here you can see us doing the medium size, which is like 8 requests of 512. And then here we're doing the min size of 8 requests of 256. And then we log out, here is the max bytes per second for the large request, the medium request, and the small request. And in this particular example, it turns out that the medium size actually had the fastest bytes per second calculation. And so from then on, you could see us just continuing to use the medium size. And again, every about a minute or so, we'll do these same checks again. And if you have this logging on, you can see us changing sizes. And so, moving on. File leasing support. So, in macOS 12 Monterey and earlier, so essentially current behavior, the model that we use is only files that were open locally on the Mac and only open with OEX lock, which we translate to the SMB share none, or O shared lock, which we map to SMB share read or share delete, whatever requests the lease and the durable handle. We only use, well, by default, we assume durable handle v1 and lease v1. The only time we didn't do that is if it was a time machine over SMB mount. For those who don't know, time machine is the macOS backup mechanism. If it happened to be a time machine over SMB mount, then we would actually check the server to see if it supports the durable handle v2 and lease v2 formats. And if it didn't support it, we would actually not allow the time machine backups over that. If we ever got a lease break, we would just run forever with that broken lease. So whatever stuff we lost, we just lost forever until somebody closed the file and reopened it. Our local data caching had completely separate logic on whatever our current lease state was. The thing to note is not that many applications on the Mac OS open files with OEX lock or O shared lock. So, Mac OS 13 Ventura. It's in public beta right now. So this is stuff coming soon. All files now will request a lease and a durable handle. And if we actually get a lease break, then we will actually, the client will periodically attempt to upgrade back to their original lease state, and it'll do so using a compound create close. Okay. The local data caching is now actually controlled by what our current lease state is. Because we now do all files, that means when we do reconnect, we have a bunch of files to try and reconnect. And then we've now moved to the assumption that, hey, if you're SMB 3 or later, you're supposed to support durable handle V2 and lease V2. So we just automatically use it, okay? Moving on again, Spotlight over SMB. So Spotlight is the macOS system-wide search feature. Allows you to find documents, apps, emails, content searching, but it is our proprietary way of searching. So again, current versions, macOS 12 Monterey and earlier. We have Spotlight over SMB. When the client connects to the server, we actually try and find to see if Spotlight is on the server. And if it is, then we'll use Spotlight. So of course, the macOS server would have Spotlight, and we would do Spotlight over SMB. If it's a non-macOS SMB server, then we use what's called crawling mode. Now, the way we determine whether Spotlight is supported on the server or not is after you mount the share, we try and open up the name pipe of MDF service. And if it opens up and we can talk to it, then the server supports Spotlight. If we can't connect to the MDF service name pipe, then we use crawling mode. And crawling mode is where the client Spotlight process essentially crawls through the share, just poking around, and it builds up a local database. But you don't have any content search. You just have some really basic search stuff. And the bad part is when you unmount that share, that database is destroyed. So when you mount the share again, it starts the crawling process from the beginning again. New and improved, macOS 13 Ventura, which is coming out. We now support WSP. So same thing. First thing, share is mounted. We would like to use Spotlight, so we will try and open up MDF service. If we can't find MDF service, we will then attempt to open WSP. And I'm not going to go over the whole specs of WSP. There's a whole protocol specification document out there that you can read. If we can connect to WSP, we will now translate Spotlight queries into WSP queries. And then when the WSP results come back, we automatically translate the WSP results back to Spotlight results. And again, if we can't find Spotlight, and we can't find WSP, then we drop down to crawling mode again. A little bit about Spotlight over WSP. You can search on things like file names, sizes, date, stuff you expect. But you can also do advanced searches like title, copyright, author, publishers, vendors. Pretty much it's a content searching engine now. You can actually do logical and or not. You can do comparisons. You can do regex.
Brad, have you been in touch with the folks at Microsoft about that? Because that was one concern that we had.
Yes.
Ago and
started
looking at it, there was.
Right, so the question is, have we been in contact with Microsoft about our use of WSP? Yes, we are constantly poking at them to say, we like WSP. We have actually talked to their protocols test team to say, can you add more WSP tests? And because for a while, We've been using WSP on our iOS stuff too, and so we like it. Tiered and online-only file supports. Again, goes all the way back. We shipped this back in macOS 11 Big Sur. So these are the bits that are involved for tiered files. There's Microsoft defined a new tag called, it's the tag of IO reparse tag storage sync. The file attribute reparse point bit has been around. The M bit's new. It is the file attribute recall on data access. This is the definitive answer bit. This will tell you specifically that open will not recall the file, but any IO operations will recall the file. It is not user settable, which is great, and it's used by newer Microsoft servers, so about 2019 and later. The O bit and the P bit have been around for a while. The problem with the file attribute offline, it's not always set consistently. It is supported by the older Microsoft servers. The P bit, the file attribute sparse file, its biggest problem is it's user settable. So it's not quite as reliable. Again, used by older Microsoft servers. So how do we handle this? So the SMB client, the file has to be a reparse point, and it has to have that magic tag. And if both of those are true, then if the M bit is set or the P or O bit is set, then we identify it as a currently tiered file. We assume that once you completely recall the file, all of those bits should be cleared. We assume that the metadata is from the actual file, except for the physical size. And the physical size is actually the amount of data which has currently been recalled. Okay? We also assume that if you're querying for or reading name streams, that will not recall the file. Stepping up a little bit layer, stepping up one higher layer to how our OS handles it. So if the M bit was set, then we know that we can open the file safely. But we do know that read and write operations are going to recall the file. If the P or O bit is set, then we have to assume that just opening the file is going to recall the file. So either opening or any sort of IO would recall the file. A process that's running on macOS, we check to see if it has the entitlement to recall the file. If it doesn't have the entitlement, then we actually deny the operation. So the typical example is Finder thumbnail generation. We always get these reports that Finder is constantly recalling all of these files, and they don't want them recalled. Oh, gosh, that ended up really, really small. So this is actually a Finder icon view. You have two files. That one there, it's kind of hard to tell, but it has a generic JPEG icon, okay? Because that right one is actually a tiered file. And then since Finder thumbnail generation doesn't have the entitlement to recall the file, it wasn't able to read the file. And so instead, it puts up the little generic icon. The file on the left is a currently, it's a already recalled files, so it's just regular file. And in that case, you can see that Finder automatically generated the thumbnail. You can also look at the same share in terminal. If you do the ls-io on that share, you could see one file as a regular file, it's just a JPEG, and you could see the other file, which is currently tiered, showing up as dateless. Now, for macOS, we call them dateless files. So that's why it shows up as dateless instead of tiered or online. Okay, and then now we move on. Shadow copies and SMB Timewarp support. Again, it was introduced back in macOS 11. So some quick definitions. What is a shadow copy? A shadow copy is a snapshot of a volume that duplicates all the data on the volume at one instant in time. What is SMB Timewarp? I'm talking about the create context, which is the SMB2 create Timewarp token. And it allows the SMB client to request the server open a version of a file or directory at a previous point in time. So the support that we added was you can now use SMB util with a snapshot command. You give it a mount path, and it'll list out the available snapshots on that mounted share. And then you can mount the share with that snapshot time. And there's various ways you can mount it. You can use mount SMBFS, mount-t. Some limitations. The mount is read-only because, hey, it's a snapshot. And then in Finder, we actually append the GMT token to the end of the name because some people will mount multiple snapshots of the same share at different times and then compare the data. And so it's nice to have the GMT token at the end to tell you which share is which. And the way it's implemented is essentially all the create requests have that Timewarp create context added. And that takes us to questions.
So the spotlight, can we disable it on the client side?
So the question is, can you disable Spotlight on the client side? Yes, you can. I don't know the command off the top of my head, but you can. But if you turn off Spotlight on the client side, it won't use WSB, it won't use anything, it'll just completely turn it off.
Yeah.
Yes.
This is like the one we discussed the other day, like similar, totally.
Oh. I'd have to look. Yeah, it's some other command line thing. No, it's like the command is something like MDS store disable something, something, something. I would have to look up the exact command.
Sorry, not very familiar with macOS. What are the practical cases where somebody would encounter a dateless file?
So the question is, when would a customer encounter a dateless file or tiered or online only file? So the Mac OS now supports dateless files. We have some iCloud extension stuff where you can say save documents or stuff into iCloud. And same thing, by default, a lot of them end up dateless. They'll have a little cloud icon with a little arrow pointing down. If you click on it, you can then download it at that time. Okay. For the SMB case, they've had, I think it's Azure File Sync. I can't remember the exact product name, but they do, they call them tiered files.
Or ghosted, I think is another term.
Could be, yeah. I think they call theirs tiering servers or something like that. And they will offload a ton of files, and then on demand you can download it. I think they do everything from what are your hot files that are constantly in use, and they keep those downloaded and so.
Cache eviction.
Yep.
So follow-up question to that. So in macOS or other similar products or pockets hosted or tiered, somebody wants to open up a text document, stuff in the background, pages it in from remote storage. So for things, again, apart from things like thumbnail generation, you skip those, is that?
Yeah, so what happens is we have an entitlement, and the process has to be given that entitlement. Otherwise, it can't recall any of the files. So like thumbnail generation will never have an entitlement because it's an optional thing, right? It's like,
What's entitled, is that like a privilege?
yes, yeah, it has to be granted a certain privilege. So any particular operation that is allowed to recall the files, they will have to have that entitlement. So yeah, it's a privilege. It's a separate security privilege that's added to them.
So in practice, last question, so something like a text editor, page event filter, they'll have that.
Yeah, yeah.
Don't have to be like an add-on.
No, no.
Hey, multi-channel.
Mhm.
You use a suggestive term, main and alternate, for the channels. Do you actually use all the channels at once? Like, are you
Yeah,
jumping across them?
so we have the list of active channels, right? And then we have one inactive channel, or I would consider it like the backup channel. The one inactive channel, we keep the channel established to the server, but we don't route any traffic over it.
Really?
And then the active channels is a whole list of channels which are all the fastest channels. Okay, so if you could have
And but you're using them all the time?
in a round robin.
Or doing some other,
Oh wait, so the question was,
I'm just trying to find your multi-channel access algorithm. It seems like you might focus on one and have a bunch of backups and alternates.
No.
But you're saying, no, you have a set of
Yeah.
channels that are active.
So the channel-
I'm confused about the idle one, but keep talking about
yeah, let me go back to the original. The question was, how do we use the channels? And so yeah, so we'll have as many active channels that we can find that are, again, the same speed and which we think is the fastest speed to the server. So you could have 6, I don't know, 1 gig connections to the server.
Yeah,
And then we,
for all server interfaces, for all client interfaces,
Mm-hmm.
all interconnected.
and then we just round robin the traffic over each channel. I think I talked to the Windows client multi-channel implementer a long time, and I said, did you ever come up with a more sophisticated algorithm for determining which channel to route traffic over? And they said, yeah, we had this really great algorithm, and it really didn't buy us anything. So round robin actually seems to work pretty well.
Okay. And so what's the purpose of the idle channel?
So that it just gives us one extra channel to fall back to, that's all. Because if you have one or more, let's say you have 3 active channels, then yeah, as each active channel goes down, we go to the next active channel, and the next active channel, okay? But a lot of times you have one fast interface. Like in this case, I had a 1 gigabit and then a Wi-Fi.
Right.
And so the 1 gigabit is my active channel, and then the Wi-Fi is my inactive channel, is my backup. So if my single gigabit goes down, then I immediately drop down to Wi-Fi. We don't want to use both the gigabit and Wi-Fi because there's such a big difference in the speeds.
Absolutely.
Okay? So yeah, in the case where you have multiple active channels, yeah, the inactive channel is,
Wrong with the idle channel, but you recognize it as available.
yeah, yeah. So yeah, it's just kept as a, one extra safety thing.
Okay.
But if you have only one physical interface, you have more than one channel, or two similar 2 gigabit Ethernet, do you also take inactive channels then?
If I have, so the question is,
You only have interfaces of same speed.
right? Yes. So the question is, if I only have client NICs which are the same speed, will I not have an inactive channel? That is correct. So if you have 4 1 gigabit NICs and that's it, those 4 will all be considered active channels. And then only if all 4 go down will we ever try and do reconnect.
Question on WSP. So you mentioned your Spotlight search engine uses WSP, the server supports it, right?
Yeah.
And 2 parts of the questions. One, the some data set. That's one. Second,
Oh, wait, hold on. So the first question is, do we have performance data showing the difference between crawling mode and using Spotlight over WSP? No, because crawling mode is really simple searches. And if you had a complex directory hierarchy and you had a file name way at the bottom, we may not find it because it's slowly poking through when it has time looking for stuff. So the performance of WSP over crawling mode would be a huge, huge, huge difference because you have a pre-generated database which just says, here's the results versus manually poking through.
So I think one way to look at it would be what do you pay for that, right? In terms of system resources, server and all that. But keep that aside. Second part of the question, beyond the native Mac search engine, these exposed us APIs to applications that can make use of WSP if they want to.
So the question
So
is,
like applications on Mac, which has to do searches, those APIs can also use WSP if your underlying NAS storage supports it.
so the question is, can other applications under macOS access the WSP functionality without having to go through the Spotlight APIs? No. So what we actually built is a Spotlight translator to WSP and vice versa. So if you want to do the search APIs, then you just do the Spotlight APIs. And
You have the option to use those APIs as an application. You could use Spotlight APIs and get the benefit of those.
yeah. So I don't know what the Spotlight APIs actually are. I'm guessing that's several layers above me.
Whether it's
Yeah,
if
but
applications use it or not, just a question.
you won't know whether it's doing Spotlight over SMB or if it's using Spotlight over WSP. It just gives you the results. And it might even be using crawling mode, which means you get really slow results back. So
So one question on tiering. Did you mention Windows 2019 onwards for a tiered file it sets that embed in the attributes?
one more time.
2019 onwards for a tiered file on the server side, does it set the embed in the file attribute?
Yeah, so the question is it that the Windows servers, the 2019 and later set the mbit? Yes. So when we were doing our tiered file support, we actually was working with Microsoft to get their bit definitions and to understand what the bits meant to them. And they had actually defined this new mbit because the previous bits were just not reliable enough. And so that's why I say it's the definitive bit answer, that it specifically says you can open the file and it won't recall it, but it's only read and write. Okay?
So you would avoid doing issuing reads for the header part of the file, which will translate to
Yeah, so if we get a read operation from an application for that file and we know that it's tiered, again, we immediately check the entitlement to say, is this read allowed to go through? And if it is, then we allow it to go through. If it's not an entitled process, then we immediately return it with an error.
Entitlement, assume it's somebody not listing the file and looking at the header part, but it's an application which actually want to read the content of the file. What's the definition of entitlement?
Oh gosh, what is the definition of an entitlement? That I can't answer very well because that's, again, multiple layers above me. It's some security model that various applications have to get an entitlement. How they get the entitlement, how they add it on, I don't know. I'm just at the bottom saying, do they have the entitlement or not? But yeah, like I'm assuming like system processes are all have the entitlement and applications probably added in somehow. And
But there is no filtering of what's the offset of the read.
no. It's just, so the question is, does it matter what the offset is? No, it's just, again, so if it's the M bit, then I/O will recall the file. Okay? So we know whether the M bit is set or not. And any sort of read or write, any sort of I/O will always be checked for the entitlement. But if it's not the M bit, it's a P or O bit, then we also add in that you can't even open the file because that'll probably recall the file. We're not sure. And I think I'm out of time.
Quick question on the multi-channel implementation. So for both, there's some evaluation you do in the beginning. For example, for multi-channel, what's the fastest settings? For bracket, what is the
Throughput.
Do you at some point reevaluate? If the link characteristic has changed, maybe it's a different set that performs better.
So the question is, do we ever reevaluate the link characteristics? So every 10 minutes, we will ping the server for its current list of network interfaces. If that list has changed, that'll start a whole new set of trials. If the client NIC list changes, so if I unplug one of my Ethernets or whatever, that will also trigger a whole new set of trials. So any sort of network changes that we see in terms of NICs, that'll trigger a new set of trials. Depending on the results of the trials, then we'll reorder the list, and then new channels may suddenly become active. So, an example I had one time, or a demo I gave one time, is I had a whole bunch of 1 gig adapters plugged in. And I started my file transfer. And then I just started pulling links out, and you could see the file transfer speed dropping, all the way down to Wi-Fi. And then I started just plugging stuff back in, and then you could see the speed start to climb back up. I think Microsoft did this demo in the original multi-channel.
Yeah, he went from 1 gig to 10 gig to, and then back or something.
Yeah. That's the wonderful thing about multi-channel. You just constantly pull out stuff and add stuff. And so we're tied into the system to get notifications when the NICs change. And again, if we have pending traffic when a NIC goes down, we just throw it onto the next active one, and we just mark it as replay.
And another quick question on the bracket throughput algorithm. So you had 3 different sets or different chunk sizes. So do you split the incoming chunk from the application layer to those?
Yes. Yeah. So the question is, with the min, medium, and max, do we break the incoming chunk size into those smaller sizes? Yeah. So the way our client is implemented is we actually report the maximum chunk size that we want from the file system above us. So like in this case, Finder happened to be giving me a 64 megabyte block. And then we will break it down into those smaller things, if it's big enough, of course, right? So a lot of times we'll get down huge chunks of data, and then we parse it down at our SMB layer and then send it across. And I think we're out of time.